62 times in 1 second. Nothing but light can travel at that speed. Light travels at different speeds through different substances. In the emptiness of space, where there are no gases, light travels at its maximum speed. In air, glass, or water, light travels more slowly. Normally, light travels in a straight line, but when it goes from one substance to another, it may change direction because it slows down or speeds up. This change in speed causes the light to bend, or as scientists call it, refract. We can demonstrate refraction in a variety of ways. If we look at this pencil in the glass of water, it appears that the pencil is bent. When this bird is fishing, it must take into consideration the fact that the fish is not where it appears to be, because the reflected light from the fish bends when it moves from the water to the air. If the bird didn't know this, it would always be striking in the wrong place. Fiber optics is a technology that is used in a number of interesting ways. The fiber optic material is flexible glass or plastic that can be as thin as human hair. Light that goes in one end of the fiber is reflected back and forth from side to side the entire length of the fiber. The fiber can be twisted and bent, and the light still comes out the other end. Fiber optics is used to send telephone calls because more information can be carried than with electric cables. It is also used to videotape in hard-to-reach places, such as parts of the human body reached during surgery. Fiber optic material is used for lamps and even sold as a fun flashlight toy. Laser light is a human-made light composed of only one kind of wavelength. Laser light can be used in a variety of ways because of its special properties. It is used at the library and at stores to read barcodes to identify products. The laser is used in operations because it can cut more accurately than a scalpel, and because there is less bleeding when laser surgery is performed. Lasers can be used to cut sheets of metal. Your CD player uses a laser to read the signal from the disc. The light from the laser doesn't wear down the disc, so the sound quality is always excellent. Holograms are made with laser light. The hologram looks three-dimensional, and as you turn from side to side, the image changes. When light strikes an object that is transparent, the light goes through. Glass and clear plastic are transparent. Translucent materials are materials that let some of the light through, but the translucent materials scatter the light so that it is hard to see clearly what is on the other side. Most objects are opaque, which means they do not allow any light to go through them. Here's an interesting demonstration. We'll use a slide projector and a dowel rod. First, we find the point where the image is focused. The white poster board will locate that spot. Then the poster board is put aside and the image disappears. Now, when we wave the dowel rod quickly back and forth, the image reappears. The image is there the whole time, but we can only see it when there is something to reflect it to our eyes. The dowel rod creates that surface, and the persistence of vision lets us see the whole image, even though the reflected light comes to us in pieces. Persistence of vision helps us see this stick man, made up of separate pictures, walk. Our eyes retain or hold on to each image for a fraction of a second, so we see the image on the slide and the man walking. Some objects, like mirrors, reflect all the light that strikes them. The image in a flat mirror is reversed. See how the letters are reversed? Some mirrors are curved either inward or outward. A mirror that curves inward is called a concave mirror. The image in a concave mirror looks upside down unless you are very close to the mirror. This makeup mirror is designed to be used close up. A mirror that is curved outward is called a convex mirror. The image is right side up. Notice with a convex mirror, you can see more of what is around you. Convex mirrors are often used on cars to help a driver see if there are other cars nearby. Amusement parks use special mirrors that are part convex and part concave to create interesting results. Images can be greatly altered by mirrors. Lenses are made of transparent material, like glass or plastic. They are designed to make objects appear larger or smaller. There are two kinds of lenses. Lenses that curve inward are called concave, and those that curve outwards are convex. Concave lenses are thin in the middle and thicker at the edges. These lenses bend light outward. Convex lenses are thick in the middle and thin on the edges. Convex lenses magnify objects. Lenses are used to help correct vision problems. Our eyes see things clearly only when the image falls on the retina. If the focal point is in front of the retina or behind the retina, things will appear blurry. Nearsightedness is corrected with concave lenses that move the focal point further back to the eye's retina. Farsightedness is corrected with convex lenses that move the focal point forward. Lenses are also used in microscopes and telescopes. The first microscope used a small water drop to bend the light and magnify it. Now microscopes use a series of glass lenses to magnify things we can't see with just our eyes. Look at these microscopic single-cell animals found in pond water. Telescopes are used to study outer space. With telescopes, we have found out a great deal about planets and stars. Light reflected from planets or given off by stars can enter a telescope and be magnified to provide us with clear details of the object being observed. Stars, such as our sun, generate light, but planets and moons don't produce their own light. They reflect the light given off by the sun. Back in 1879, Thomas Edison demonstrated a new form of light generated by an electric light bulb. Though he didn't invent the light bulb, he did produce the first practical bulb. The wire inside the bulb is very thin, and when electricity flows through the wire, it heats up and gives off light. The bulb part, which is made of clear glass, has had the air removed so the filament won't burn out quickly. This is called an incandescent light. It glows because electricity heats up the small wire called a filament. Fluorescent lamps work a little differently, as they are filled with a gas that gives off ultraviolet light when electricity passes through it. This ultraviolet light causes a phosphorescent coating on the inside of the tube to glow.